All right, so two things about yesterday. One, I keep running into trouble because I'm being an idiot and trying to roll my own binary functions, and I should just use ones that are built into Python. The second is someone on YouTube pointed out that the reason my first version yesterday didn't work is because I didn't strip the new lines off the end of the text, which I do every day and say I probably need to do that. And then yesterday I didn't do it, and I did need to do that, and because I'm an idiot. So today, let's try not to be an idiot. Hopefully, I won't be an idiot today. Okay. Catch your person, I'll try and book a new flight to your vacation island. Due to the storm, all direct flights have been canceled, but a route around you take it. You wait for your flight to check in with the Alice back in the North Pole. We memory game, so play the rules. This game takes turns saying numbers. They haven't taken turns reading from a list of starting numbers or puzzle input. Each turn consists of the most recently spoken number. That was the first time the number has been spoken. The current player says 0. Otherwise, the number had been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. So after the starting numbers, each turn results in that player speaking either 0 or an age. The game ends with itself. The question for you is, what is the 2020th number spoken? Okay, so here's my prediction. My prediction is that in the second part, they're going to ask you to be like the 700th million, and so the version that you do won't work. That said, let's play a game. Starting numbers, because they always do that, and that will return us an iterator of ints. Okay, so from typing import list and iterator, and so despite that, I'm gonna solve it their way, and we will say last seen is dict from int to int equals this. Okay, and we're going to the last number spoken. The last number spoken 0. The next number to speak is 0. Okay. Here are the last numbers spoken. Right numbers. Okay, so for I and enumerate starting numbers, last seen n equals I. Okay, and otherwise, the number has been spoken before. 036. Now consider the last number spoken 6. Since that was the first time the number has been spoken, the fourth number is 0. And let's say is new equals false. If n in last seen, or let's say is new equals n not in last seen, and okay, so now what we want to do is we want to yield in, since it's an iterator. Okay, now we'll do while true. If is new. So if we have a new number, first number is spoken, fourth number is spoken 0, assuming the last number is spoken 0. Difference between the turn number was last spoken, the previous turn for, and the turn number of the time it was most recently spoken before then. Okay, so rather than is new, I'm going to say gap equals none. If n in last seen, gap equals I minus last seen in. Else gap equals none. Last seen n equals I, yield n, while true. If gap, so if there is a gap, n equals gap, else n equals 0. If n in last seen, gap equals I minus last seen n, else gap equals none, last seen n equals I. I plus equals 1. Variable I is unbound. So I equals, let's do this. Import Iterators. For I and Iterators.count, let's say len starting numbers. If gap n equals gap, otherwise n equals 0. If n in last seen, gap equals that, otherwise gap equals none. Last seen n equals I, yield n. Okay, and so now let's say game equals play game, and it was 036. Output equals next game for blank in range 10. So let's run it and see what the output is. I'm in the wrong window. Advent 2020 day 15.py. Really? That should be text. 03603311040. So 036 0331040. Okay, so that looks pretty good. The game ends whenever the elves get playing sick of dinner. And so now let's say def n 2020 starting numbers, which is a list of int, and it's going to return an int. And let's say game equals play game starting numbers, and the 20th number. So for blank in range 2020, n equals next game, return n. So how can n possibly be unbound? That doesn't make any sense. Anyway, so let's say in 20 of 036, is 436. Let's see if that's right. 436. Good. Assert n 2020 of 036 equals 436, and they give us one more example, which is let's say 312 1836. That seems right. Your puzzle input is that, so I don't even need that. Okay. Numbers equals this, print in 2020 of numbers, and so let us run it, and it says 758, so let's try it. That's the right answer. Okay. See, I know how these guys work. 30. That's actually not that many. I'll probably just do it by brute force anyway. Def in 30 starting numbers list int. Yes, I could use the same function for that, but I'm not going to. And let's see how long this will take to run. No. For I, if I mod 1000 equals 0, print I divided by, this should still be pretty fast. Not pretty fast, but I think it should be fast enough, to be honest. We'll see. Maybe not, in which case I'll need to be more clever, but so it's only 30 million, right? Like, we're close to 30 million. So there's probably some trick to make it faster, but it's not worth my while to do that trick. 814. All right. Well, that wasn't too bad. I don't I don't entirely get it. Like, I'm sure there's probably some like clever thing you can do, but it just didn't take that long to do the non-clever thing. So anyway, it worked, and that's good enough. So what's interesting here? What's interesting is one, using infinite iterators or generators, which is a nice trick. And so what I said is, they want to play this game where where they speak numbers, in order. Essentially, it's forever. It says the game ends when they get sick of playing, right? So I say, you know what? I'm not going to worry about how long the game is. I'm just going to create like a lazy sequence of what happens, and then that'll be good. And we'll just take as many as we need. And so they say that if the number had been spoken before, the current player announces how many turns apart the number is from when it was spoken before. So we need to remember the last time each number was spoken. And so what I did is I made a dictionary that says this is the last time I saw this number. And then basically I'm going to need to say like what the gap is. And so I ended up using this variable called a gap. And so what I do is for each of the starting numbers, if I've seen it before, the gap is the current timestamp minus last time I saw it. Otherwise, the gap is none. So I'll just keep doing that and say gap is either time since I last saw it or none if I've never seen it. And then I'll say this is the time at which I last saw it, and I'll yield it up. So this will be an output of my iterator. And now, once I get past the starting numbers, I use itertools count, which just starts counting. And so if there's 3 starting numbers, that will be I equals 0, I equals 1, I equals 2. And so this will start at I equals 3. And that will give me, again, the index. And basically, I just recreate recreate this, right? Um, so I really could have done this in one loop if I'd thought about it and just said for I in like count 0. Um, so so like for I in itertools dot count 0. Um, if I is less than len starting numbers, n equals starting numbers I, you know, elif gap n equals gap, else n equals 0. Um, and so, now I've changed it and just done it this way. Um, and I don't want to print this again, but I think with that change, it will still do the same thing. 758, which I think was the right answer in medium test pass. And so now I only have one loop instead of two loops, so that's slightly nicer. So can say still in starting numbers, use them. Number seen before, so say the gap, and then otherwise a new number, so say 0. And now saw this already, so figure out the gap. First time, so no gap. Update last seen and yield. Okay, so so good. So now we play this game. We generate this infinite sequence, and I just wrote this function. Obviously, I didn't need to write two functions. I could have taken this second thing as a parameter. That would have made more sense, but I'll just leave it as it is. And I say game equals play game. That generates the lazy infinite sequence. And then, basically each time I call next on that lazy infinite sequence, it generates and spits out the next element. And so I say I just want to do that 20 times and return whatever I get. And then for the 30 million, I just do it 30 million times. And possibly there's some trick, but I looked at this and said 30 million isn't that long. I'll just run it and it will work, and it worked. So that was not too much trouble, and I'm happy about that. Hopefully you're happy about that too, and I will see you next time.